All right, so now we are on page 3. So with page 3, the graph, we've got to say which of the following statements is true. So I'm going to go through each statement and just put a T or F. So the first part might look a little confusing. This just says, where's your function below 0, which for us, we just want it on the negative interval. So the negative interval is from here to here. So I'm going to need some information. So I'm going to go ahead and mark where it starts, where it ends, and then where it crosses the x-axis. So when I want to know where is it negative, this is saying it's negative from when x is 0 to x is infinity, which is happening on the graph. So this is a true. The range has a lowest value of 2 and a biggest value of infinity. So when I scroll from the bottom up, the first y value I hit is actually negative infinity. That's my smallest. And then if I keep going, then I'll hit the 2 that's here. So this one is not correct. It should have been written like this. And then that would have made it true. All right, my domain, my small x is -4, my big X is infinity. So if I scroll from the left to the right, the first thing I hit is -4. And then if I keep going to the right, I get to this infinity. So this one's true. And this says if y is -1, then my x value is 5. So I'm going to go to where y is -1, that's all along here. And is my x 5, which it is. This point actually here is 5, -1. So my answer choices are 1, 3, and 4, so I will choose option D. All right, another domain question. So which of the following has that domain? So it can happen, and this is a typo, that should not be there. So from -2 to 5, then it takes a break, and it goes from 5 to infinity. So if I were looking at a picture here, -2 to 5, and then 5 to infinity. So when I go for this, that's what where I'm gonna start. So let's just start with the first one. So x in a denominator, or I'm sorry, x in a square root, so x plus 2 has to be greater than or equal to 0. And then and so let's go ahead and move the 2 over. And then x minus 5 is in the denominator, and that cannot be 0. All right, so if I made a picture for this one, I've got -2, here's 5, closed for -2, open for 5, and it goes over, which, hey, that's our answer choice. I don't have to do any more. This is what I got. Okay, let's just show you one more. So on this one, the only thing I have to worry about is that x minus 2 is in the denominator. So this can't happen. So if I add the 2 over, x can be everything but 2. So if this were a number line, not 2, but everything to the left, everything to the right. And then I could say it's from -infinity to 2 and 2 to infinity. Since this is multiple choice, though, I'm going to stop there because 7A is the correct choice. All right, which of the following statements are true for the inverse? So we're actually going to find the inverse. So I'm going to switch f of x to x, because it was y, and x to y squared, and now I'm going to get y by itself. So I'm going to add 3. So again, I just added 3. And then I'm going to square root both sides. And I got to square root all of this. So just make sure all of x plus 3 is in that check mark. All right, here's the inverse function. And then we still have the regular function. But let's go ahead and go through these. So the domain of the inverse function is -3, 0. Now, I know we don't have a graph of this, but if I did graph this, this says my shape would go left 3. So if it starts at 0, 0 and it goes left 3, then I'm right here. And it's a square root, so it's just going to go like that. And so if I look at my domain, I start at -3 for a small x, infinity for a big X. So this one is true. The inverse has an x-intercept at 3, 0. So x-intercept just means it's crossing the x-axis at 3, 0. In my picture, I can see that it's not crossing the x-axis at -3, 0. But if I didn't have a picture, what I could do is take this x value, this y value, and plug it into the inverse. So using this equation, I could put 3 in here for x plus the 3, and in for y, I would put the 0. And square root of 6 equaling 0 does not happen. So that's why that one's false. Next question, the inverse function has an x-intercept at -3, 0. Well, I can see that. It's right here. But if you couldn't see that, again, I could take this x being -3 and y being 0, put it in the inverse function. So -3 in for x, 0 in for y. And as it turns out, yes, this one would work. This one is true. All right, a point on the inverse function is 22, 5. So I think the most straightforward way to do that is this is an x, this is a y. Again, use this equation. Put 22 in for x, put 5 in for y. And yes, the square root of 25 is 5. 5 equals 5, so that is true. So we have another 1, 3, and 4, so option C. All right, here's a little note. Okay, some of you don't listen, you just watch, so turn on the volume because you need to hear this. All right. Multiplying, we make houses. We don't have very many adding and subtracting, but adding and subtracting, we stack like terms. So let's just start with the adding and subtracting. All right, stacking like terms. We are looking for things to be alike. And as it turns out, I do have square roots of 6s. So how many square roots of 6s do I have? I have 2 of these square roots of 6s. Now, when I stack this one, I'll put a 1 here. These are not alike. This is a no. So I will get them alike. So I'm going to go to the 8. Here's the 1. I can break 8 down to the square root of 4 and the square root of 2. The square root of 4 can become a 2. That multiplies the 1. And now I can bring this over. And now I have like terms. So if I add these up, I get 5 square root of 2. All right, let's go to our houses. Okay, exponents, doesn't matter, we're making houses. So here with exponents, I'm gonna have a house for my numbers, my x's, and my y's. And remember, negative exponents move. So 3 goes here, x squared moves down, y squared stays where it is, 4 stays where it is, x squared stays where it is, y to the 4th stays where it is. 2 is still in the denominator, but this x to the -3 will move to the top. So which house do you want to clean up first? I probably think that this is the easiest house because going for my answer, I've got y to the 6th. The next house I'll clean up is this house, and I just noticed real quick that these squareds cancel out, so I'm only left with x cubed. And then in my first house, I noticed that 4 can divide by 2 to become a 2, and then I can multiply the 3 and the 2 for a 6. So I don't have anything in the denominator. If you want to put a 1, you can, but you don't need to. Not in the denominator. All right, second problem. This has parentheses, so this will distribute to every exponent. Now, x has an invisible exponent of 1, and so does 2. So I'm going to distribute. All right, so 2's new exponent is -2, x's new exponent is -2, and y's new exponent is 8. So this is gone. All right, houses. So in the top, x to the 3rd, y to the 4th. This 2 will move to the top. This x will move to the top. And this y will stay in the bottom. So easiest house maybe, I don't know, 2 to the 2nd power is 4. x2 and x3 make x5. And then here I'll subtract them and end up with 4y's in the denominator. All right, next problem. So we do have fractions. I want to remind you, you do have an option for a calculator here, and I'm not going to stop you from using one. But what's going to happen here is exponent rules. I will only have one house because everything x's. Here go my parentheses. I'm going to distribute, and I will not be using a calculator. So over here, if I take 5/3 times 3/2, what I hope you notice is that these 3's can cancel out, and I just have 5/2 when I'm done. So that x will now have a 5/2 power. And then when I take 3/2 times this 1, well, anything times 1 is just itself. And so from here, what I can do, I have to add the exponents, and 5/2 plus 3/2 is 8/2. And maybe you notice that 8/2 is just 4, so when I'm done, I have x to the 4th power. Not too bad with our fractions. All right, next one, we do have some houses. 2 stays where it is, R1 moves, R to the 1/4 stays, 8 stays, and the other R stays. So let's just get the simpler house done. 2 8s can become 1/4. And as far as these fractions go, exponents go, let's go ahead and just get this down to R2. And now I'm going to subtract. And I think we could do this without common denominators. If I have 2 and I subtract 1/4, so I have 2 cups of water and I pour a cup out, I still have 1 3/4 cups left, which then I can do 4 times 1 for 4, add the 3, and get 7/4. So the question is, where are the 7/4? They're in the denominator because 2 is way more than 1/4. So when I'm done, I have a 1 in the numerator, I have a 4 in the denominator, and I have an R to the 7/4 in the denominator. All right, continuing with our houses, but radicals. So in our first couple problems, the main thing to remember is that you want the smallest number inside the check mark as possible. Okay, and how I go about these problems aren't, again, necessarily the fastest way or the best way, but just trying to come up with a pattern to it. Okay, houses, non-check mark numbers, excuse me, check mark numbers. All right, always start in the check mark house. So 12 is not perfect, but it does have parts that are perfect. So I think that's what most of you might do. So as I go through and I clean up the house, I'm going to cross old stuff out. So that can become a square root of 4 and a square root of 3. I will bring down this square root of 3. The square root of 4 can become a 2, which can now move into this house. And the idea of simplifying is I could multiply these 3, but I would want you to notice that we do like pairs and square roots, because this could become just 3 times 3 is 3 squared. I like the pairs. So that can become 3 squared. And when you square root something that's squared, they just cancel out. And now that 3 can move to this house. So my right house is totally empty. And when I multiply all of these numbers, right? So I don't know the best way for you to multiply, but I'm going to get 6, -8, multiply those, and I get -48. All right, next one. So here's -2 in a house, square root of 4, square root of 8. So I notice immediately that's perfect. It can move out. The square root of 8, I'm going to break down into the square root of 4 and the square root of 2. The square root of 4 is perfect, so it can move out into the other house. So when I multiply all of these, I get a -8, and I still have a square root of 2 in my check mark. All right, let's go to the next one. So houses. All right, start in the check mark house. So 24, not perfect, but I could break it up into the square root of 4. The square root of 6, I'm just going to bring that square root of 2 down. The square root of 4 is a 2, so it can move out over here. I'm going to go ahead and now multiply these together. And hopefully you see that the square root of 12 is actually, parts are perfect like this. Again, not necessarily the fastest way or the best way. I'm just trying to do everything consistently the same. So this square root of 4 can now move over to this house. And when I'm done over this house, I have 8 times 2 times 2. So 2 times 2 is 4. 4 times 8 is 32. And then I'll still have that single radical there. All right, so again, not necessarily the fastest, just trying to do all the problems the same. All right, so here we have floors. So we have 3 here, square root of 45 here, square root of 9 here. All right, so for the most part, we've just been picking apart, whoops, everything. I have a little typo there. Let's fix that. All right, so 45. 45 is not perfect, but I can turn it into 9 and 5, okay? And what I do notice now is the square root of 9 is perfect. It's a 3 that can move over here. And then the other thing that I notice is these 5 square roots of 5s can just cancel out. So when I'm done, the right house is empty. The other house, 3 times 3, I get an answer of 9. All right, next one. Let's go to our houses. All right, starting in the right house. So what's perfect? Well, 4 is perfect. It can move out. X to the 6th is perfect. It becomes x cubed, just cutting that 6th power in half. 7, there's nothing about 7 that's perfect. So we do still have an issue because the last issue is I have a check mark in the denominator and they don't like that. So I'm going to extend the bar out, fix it with this. What happens in the bottom is you get a pair of 7s. So you could look at it like this, or you get the square root of 49. Either way, when I take the square root of this or the square root of this, I end up with a 7. And as far as the check mark that's left in the numerator, we've already said you can't do anything with it. So in my left house, as far as my numbers go, I have 2 times 2, which is 4. 4 times 7 is 28. The x to the 3rd. And then I have a square root of 7. If you want to put something in the denominator, you can put a 1, but you don't need a 1. All right, next problem. So again, breaking up my houses. All right, in the right house, I immediately notice the square root of 4 is perfect, so it's going to move over here. 12 is not perfect, but I can break it up. So 4 and 3, and the 4 can move over here now. And that house is pretty clean except for the mess of, let me move this down a little bit. The square root of 3. Can't have a check mark in the denominator, so I fix it. This is how I'm fixing it. And again, when you get to this, you can think of this as a pair of 3s. We like pairs, or the square root of 9, whichever you prefer. When you take the square root of this or this, you get a 3. And now we're ready. So in my left house, when I notice a 2 in the top, can take out a 2 in the bottom. So here goes my answer. I'm going to have a 4 in the numerator, a 3 in the denominator, and in my other house, I'll still have a square root of 3. All right, that was that whole check mark section, and I know that took longer. We're just going to finish up this problem, then make a new video. So what is the equivalent form of the expression? So you might not think you can make houses, but what I want you to see here is that this 4th root of x is actually x to the, there's a little 1 there, 1/4 power. So I can take x squared and x to the 1/4 and add these exponents. So if I add 2 with the 4th, I get 2 and 1/4. And now I can turn it into a mixed number. 4 times 2 is 8. 8 plus 1 is 9. And I get 9/4. So I'm looking for x to the 9/4, which I don't see. I see check marks. So I can go back to a check mark. Remember, the denominator goes here, the exponent goes here, and my answer is C. All right, that is our 3rd video.